Good morning everyone. I am Dr. Subha Gaurab from the Department of Physics, SS College, Hailakandi, and today I am very happy that I am going to take the very first class of HS first year on physics. The topic with which I would like to start off with is error. ERROR, error. Now I hope this is a term which is known to all of you since your childhood days. But today we will be discussing mainly the concept of error from the perspective of physics. In physics, what we mean by error, how to deal with it, and all that. Now before I begin, I would like to say that the foundation of science or physics in particular lies on experiment or experimental finding. And the respective discovery of new law, principle in physics or in any subject of science is acceptable if it is experimentally approved, or rather I should say experimentally verified. That means if we come up with any new thing, until and unless it is being experimentally verified, experimental proof is established, experimental evidence is being provided, nobody is going to accept my idea. Now the question is, when we will be performing the experiment, we should be very careful about accuracy. Now whenever I say when we will be performing some experiment, that means when we will be having some observation, we will be measuring something. In physics, whenever we measure something, we call it to be our observation or doing some experiment. If I tell you that you please give me the length of this pen, say this is a pen, say this is a pen I draw, and I ask you to give me the length of this pen, then the thing which you will be doing is nothing but observation. You need to take lots of observations to ultimately give me the length of this particular object. That is all about doing experiment. Now instead of asking you to give me the length of this object or length of this pen, I can even ask you, give me the weight of this pen. Then definitely you will be doing something else. But even at that time also, you have to perform some experiment. You have to take a lot of observations. Fine? So this is about doing experiment or observation or measuring. Now, in the context of error, let me say that suppose the actual length, suppose the true length of this object is say 5 centimeter. Just roughly we are considering, say the length of this object, let it be pen or anything I call, let it be 5 centimeter. Now remember, this 5 centimeter is the actual length of this pen. And I have assigned the work to you telling that please give me the length of this pen. Then what you will do? You will take a scale or some other measuring device, you will measure the length of this object and will give me the answer. Now, do you think if you measure the length of this pen say 50 times or 100 times, every time you will end up with getting 5 centimeter? Certainly not. Some of you may get the result of the length of this object to be say 4.9 centimeter. Some of you may get 4.8 centimeter. Some of you may get 4.95 centimeter. Some of you even may get 5.1 centimeter and so on. These are just arbitrary figures I am writing just to explain what is error. Fine. Now, some of you have got 4.9 centimeter, some of you have got 4.8 centimeter, some of you have got this much. Now say, let us for example, I am considering this result which is being measured by someone of you. Now for this particular measurement, when I have got the result to be 4.9 centimeter, is it 100% correct? Definitely not, because the very correct value of the length of the pen was 5 centimeter. But instead of 5 centimeter, what we have got is 4.9 centimeter. That means clearly there is an error. Now how much is the error here? It is 5 minus 4.9 centimeter. Don't forget to put the unit. And the result comes out to be 0.1 centimeter. And this is the amount of error. This is the amount of error. Now, so I can say that error is nothing but this 5. 5 is what? It is nothing but the true value, the actual value of the length of the pen. So this is true value. In short, I can write TV minus 4.9 is what? It is the measured value. It is the obtained value. It is the value which you have obtained through measurement. So I can write it is the measured value, or it is the obtained value, or it is the experimentally obtained value. I can say any of these terms. So true value minus measured value. MV say I am denoting. So you remember the very first definition of error. Error is nothing but the subtraction between the true value of any physical quantity with its measured value. Fine. Now whenever we do some experiment, what is our objective? Our objective is to reduce the error. Now if someone of you find the error to be 0.1 centimeter, someone else of you may find, for example in this case it will be 0.2 centimeter. Here it will be even less than 0.1, it will be 0.05 centimeter. So you see, from case to case the amount of error varies. And the one or the case in which the amount of error will be least or very less, it will be considered more accurate. Fine. So in physics, accuracy means you have to come up with lesser and lesser amount of error. Error is what? It is nothing but the true value minus measured value. Now let me explain to you what are the different types of error that we come across in physics. What are the types of errors? Types of errors. Errors are broadly classified. Errors are broadly classified into two categories. One is called systematic error. Systematic error. Another is called random error. Now let us try to understand systematic error. Systematic error. The very first point of the systematic error is that systematic error occurs due to miscalibration of the instrument. This is very, very important. It arises because of miscalibration. Of the device or the instrument with the help of which you are measuring. First point regarding systematic error, it arises because of miscalibration of the instrument. I should explain what is miscalibration. Second point is that systematic error have got same size and sign for all its measurements. Fine. Now let us try to understand what is meant by miscalibration of the instrument. Suppose you have gone to a jewelry shop to buy gold and you will find a digital weighing machine. Say this is the digital weighing machine, and here there will be the display. where you will see how much is the weight of the gold that you have purchased. Now imagine a situation. Suppose you want to buy 10 gram of gold. You want to buy 10 gram of gold. You want to buy. So what the shopkeeper will do, they will pour some gold here, and the moment when it shows 10 gram here in this display, you will say that okay, I need this much amount of gold, it's okay. But if the instrument, if the digital weighing machine is such that, and there is, you cannot rule out the every possibility also, if the instrument is such that, if the condition is such that the machine shows an extra 5, not 5, say 0.5 gram for everything that is poured over here. Suppose the shopkeeper puts some gold here. Fine. And the condition of the machine is such that anything you put over here, its weight get added with 0.5 gram. In that case, here, if the reading comes out to be 10 gram, then actual amount of gold the shopkeeper has to put here is 9.5 gram, because that 9.5 plus 0.5 gram will give you 10 gram. But this 0.5 gram is only known to the shopkeeper. You don't know. I don't know. I being a customer, I don't know. This is their instrumental error, or they have calibrated. They have set the instrument in such a way that if anything you pour over here, its weight get added by an amount of 0.5 gram. So actually 0.5 gram here serves to be the, or it happens to be the error. Therefore, if we want to get the actual amount, how much is the gold? Here the reading shows 10 gram. The reading shows 10 gram. But as this device has got an error of showing 0.5 gram extra, 0.5 gram extra, then the actual amount of gold that you were buying here is nothing but 10 gram minus 0.5 gram, and answer will be 9.5 gram. So this is an error. There is an error of 0.5 gram, and this error is due to miscalibration of the instrument, due to malfunctioning of the instrument. Or rather, actually the correct precise term is miscalibration, because the instrument was calibrated in such a way that it has to show, it has to exhibit an extra 0.5 gram for benefit of the gold sellers. So now you understand 9.5 gram. If it shows 10 gram, the actual amount of gold that you will be having is 9.5 gram. Fine. So this is the amount of error. Now this 0.5 gram error will remain same for all the measurement. It means it does not matter whether you want to buy 10 gram gold, or you want to buy 20 gram gold or 30 gram gold, whatever is the amount of gold you intend to buy, for each and every measurement there will be an error of 0.5 gram. Suppose I have gone there to buy 20 gram of gold. Then here if it shows 20 gram, fine. In reality, actually, it will be 19.5. So now also the amount of error is still 0.5 gram. That means the amount of error, which is 0.5 gram, remaining same all across the measurement. Means it does not matter the weighing machine I use for measuring 10 gram gold or 20 gram gold or 50 gram gold or whatever is the amount. Therefore, we say systematic error has got the same size. Means the amount of error remains same for all the measurement. Now comes the sign. Now here you see beautifully, then the error is 0.5 gram. In order to get the actual value of gold, actual amount of gold, you have to subtract this amount 0.5 gram to get the actual amount 9.5 or 19.5. So here we have to subtract the amount of error. So here error is being subtracted. Now you imagine a situation, if the situation would have been such that, if, there is an if, I am considering a different situation. suppose something like this. Suppose you have gone to a grocery shop to buy 25 kilogram of potato. You intend to buy 25 kilogram of potato, and there is again a digital balance, because 25 kilogram of potato, if you were to measure at a time, then your hand balance will not work. So 25 kg potato you have to measure, you have to buy, and there is again a digital machine. Do you think the digital machine, weighing machine with the help of gold was measured, that will work for measuring 25 kg potato? Certainly not, because sensitivity matters. For measuring gold, the instrument has to be very, very sensitive. It must have the ability to measure even the smallest amount of gold. But for potato, it is not required to be very, very sensitive as the weighing machine required for measuring the gold. So, suppose you have gone to a shop to buy 25 kilogram of potato. Now say the condition of there is again reading. Now suppose the condition of the machine is such that say here there is no 00, it is not showing 00, it is showing minus 50 gram. Then what you have to do, you have to pour 50 gram balance here to bring 00, because you will buy 25 kg potato after getting ensured that the display of the weighing machine shows 00. If it shows minus 50, maybe as a customer you will not say anything, but the shopkeeper will not allow you to make the measurement with minus 50 gram. Now suppose I consider that the machine shows minus 50 gram, fine, then you need to give an extra 50 gram to make it 00. Thereafter, if you get the reading 25 kg by putting so many potatoes here, suppose potatoes have been put here, and reading comes out finally to be 25 kilogram, fine, and think that there is no 50 gram weight here, only potatoes you have put here on the balance, and the result comes out to be 25 kg. But you know that this machine requires extra 50 gram to get the reading to be 0. That means if there is no extra weight and you come up with 25 kg reading here, then the actual amount of potato you will be having is 25 kilogram plus 50 gram. Now you see the situation here. Here, in order to get 25 kg, if you just concentrate on the reading 25 kg, then the amount of error gets surplused. 50 gram. So you come up with an extra 50 gram of potato here. But in this case, you are actually short of 0.5 gram. So here you see the amount of error was subtracted, and here you see the amount of error get added to your quantity. So in this case, actually the amount of the error, not the amount, the error is negative, and here the error we consider to be positive. So conclusively I can say error can be positive as well as negative. Error can be positive as well as negative. We are talking about systematic error. It can be positive, therefore it is said the systematic error will have same size and sign for all its measurement. If you are using this device for all along the measurement, there will be a surplus 50 gram. If you are using this device, then all along your measurement you will be having shortage of 0.5 gram. This is the meaning of the term systematic error having same size and size for all its measurements. Now let us focus on to random error. What is random error? We call random error occurs by chance, or to be more precise, I can say random error occurs due to unknown cause. Unknown cause. That means cause is not at all known to me. In earlier case, in systematic error, the cause was known to us, that 50 gram or 0.5 gram here and there, fine. But random error occurs due to unknown cause. Cause is not at all known to me. So I can't even say that this is the reason why random error occurs. Fine? Means some error occurs. I don't know even how much is the amount of error. Fine? It is not very, normally we cannot just assess the random error. So, random error can occur due to first unknown cause, of course. Say you are measuring and temperature is very, very high, and due to this temperature you could not concentrate properly while you were measuring. This could be one of the reasons. Suppose my eye condition is not so well to see the very fine divisions in a scale, and due to this I am having some error. This can also be a reason of random error, and there are lot more reasons. Therefore, specifically, we cannot say that the cause of the random error is this or that. And as the cause is not at all known, so it is difficult. And this random error can be different in different experiment. You remember, systematic error have the same size and sign for all measurement. But if it is a random error, then it will be different in different cases. And moreover, its reason is also not known. So really the situation is difficult here. Therefore, as of now we have understood what is error. It is the subtraction between true value and measured value. Again we have come to know what are the types of error: systematic error, random error. Systematic error occurs due to miscalibration of the instrument. Random error occurs due to some unknown cause. Systematic error can be calculated, can be evaluated, and hence it does not pose any severe threat to our measuring system. But as the cause of random error is not at all known, so really it's a problem. Now we need to define a term called accuracy. Many a times we call accuracy. All of us want to be more and more accurate, to lead better and better life. Now what is accuracy in physics? Measurements made with extremely small random error is said to be of very high accuracy or precision, or very high precision. Accurate measurement means extremely small random error. If I measure something and while measuring that amount of random error is very, very small, then I will call that measurement to be very, very accurate. And therefore it is correctly written that measurements made with extremely small random error is said to be of very, very high accuracy or precision. So I think as of now we have understood that the main problem of error is with random error, because if it is a systematic error we can calculate, so we can add or we can subtract to get the actual real amount. So it is not at all a problem. But the problem lies with random error, because the cause of random error is not known, amount of random error is also not very precisely known. So to get the correct result of any physical measurement or any measurement, the main problem lies with accuracy and consequently with random error. Now let us see how to minimize random error, because I have discussed measurements made with extremely small random error is considered to be very, very accurate. So how to take very, very accurate measurement? How to ensure that our measurements are very, very accurate? For that we have to ensure that we have very, very small amount of, or rather extremely small amount of random error. So the next question which comes to our mind automatically is how to minimize. How to minimize. That means reduce random error. How to minimize random error. Sorry. This is the main task. So let me tell you that random error can be minimized by taking repeated measurements of a particular physical quantity. Repeated measurements of a particular quantity. Suppose on the first part I have said that I have given you a pen or some object and you want to find the length of this pen. You have to give me the length of this pen, whose actual value was 5 centimeter. But this 5 centimeter I have not given to you. This 5 centimeter is already just known to me. None of you know what is the actual length. So some of you will come up with result 4.9, 4.8, 5.1 centimeter like that. Now whose measurements I should consider to be very accurate? The one which will be having very, very small random error. Now how to reduce? So some of you may find the length of this pen only once and give me the result. Some of you may find the length of this object twice and thereafter take the average and give me the result. Some of you may take the measurement of the pen 5 times and thereafter take the average. Fine? So the advantage of taking observation many a times is that it reduces the random error. Fine? You have seen that if we look at cricket, then the players whose average score is much more, we consider himself to be great player. We may find few players who will flourish in 1 or 2 innings, but the one who have consistently done very well and thereby considerably increasing his average will be considered to be great player. Similar is the case in the case of measurement too. In order to minimize random error, so that our measurements can be more and more accurate, we have to take repeated measurements of a physical quantity. Of a physical quantity means physical quantity could be anything that we are measuring. Fine? It can be length, it can be time, it can be volume, it can be mass, it can be pressure, force, anything. Anything which we want to make measurement, which we want to measure is considered a physical quantity. Now suppose I have said that you are to measure the length of this pen, and even say I also don't know what is the actual length. It may happen. Arbitrarily if I tell that give me the length of this pen, how can I know what is the actual length of this pen? It is impossible for even me to know. But in order to calculate the error, I have to know true value. So how to know the true value? True value is not at all known to me. Fine? So in that case, true value is what? Suppose first when I have kept the pen here, I have taken a scale and measured the length of this pen, I have found the result to be say x1 centimeter, say centimeter. Again I have taken the same scale, measured the length of this pen, I have found out the length to be x2. Thereafter again, say I have measured the length of the pen, found out the result to be x3, and so like that, say I have measured n times, x4, x5, x6, like that, n times I have measured. Fine. Now if I have measured only twice, then the average would have been x1 plus x2 divided by 2. If I have restricted to 3 times, then x1 plus x2 plus x3 divided by 3 would have given me the average. So as I have taken n times the observation, so all these individual plus divided by how many times I have taken the observation n times, So this will give me x average, and this x average is nothing but the true value, because true value is not at all known to even me. So how to assign the true value? True value is nothing but the average value. True value is nothing but the average value. Here you just concentrate here. X1 is the result that I have obtained when I have first time measured the length of the pen. That means it is the result in measurement 1. X2 is the result which I have obtained when second time I have measured the length of the pen or the object. X3 is the result that I have obtained when third time I have moved for measuring the length. So like that, Xn is the result corresponding to nth observation. So if I take the average of all the measurements, the result comes out to be, say, X average. I denote the average of all the measurements by X average, and this is considered to be the true value, because in order to calculate the error, I have to have the true value and measured value. Now these are the true values. This is the true value. True value is a single value. Fine. Now X1, X2, X3, Xn are the individual results that I have obtained while measuring the length of the object. Then how much is the error? For that, true value I have calculated very good, but I don't know all other factors, all the other errors. So for that, first let me define a term. I denote it by delta. This triangle is called delta. Delta x1. Let me write, and thereafter I will explain. This is nothing but x average minus x1. Now you see, x1 is what? It is the result that I have obtained while first time when I have made the measurement. I have measured the length, the result I have got is x1. Now what is the difference between x average, the true value, with my first observation, with my first result x1? That is given by delta x1, and this is called absolute error. A new term, absolute error in the measurement one. That means first time during my first measurement, first time when I have measured the length of the pen, then the amount of absolute error I have had in my observation, I have had in my measurement was delta x1. That means when I have actually calculated x1, the amount of error that I committed, the amount of mistake that I committed is nothing but delta x1. But this delta x1 is precisely related to only my first observation. It has nothing to do with the results that I have got while measuring second times, third time, fourth time, and so on. Therefore, delta x1 is very, very specific. It is, you can say, it is the mistake that I have committed during my first observation. Similarly, I can define delta x2. This is x average minus x2. And I can say it is absolute error in the measurement 2. That means second time when I have found actually the result to be x2, that time the mistakes that I have committed is delta x2. So this is called absolute error in the measurement 2. Like that, I can define delta x3, delta x4 and delta xn. Delta xn will be x average minus xn, means during nth observation when I have obtained the result xn, that time the mistakes that I have committed due to unknown reason is nothing but delta xn. So this is absolute error in the measurement n, means during my nth observation the amount of error that I committed is this one. This is called absolute error in the measurement n. So now you know x1, x2, x3, xn are the individual results that I obtained, and delta x1, delta x2, delta xn are the individual absolute errors in my measurement. Delta x1 was the absolute error during my first measurement, delta x2 is the absolute error during my second measurement, delta x3 absolute error in my third measurement, and so on. So these delta x1, delta x2, delta xn are the absolute errors. So if I take n times measurement, if I take 5 times measurement, if I measure the length of the pen 5 times, then I will have delta x1, delta x2, delta x3, delta x4, delta x5. So I will have 5 absolute errors. Now out of these 5 absolute errors, which one is best? Means which one to consider. Fine. So out of these, say instead of n, let me tell you that I have taken the measurement 5 times. Then here I will have only x5 divided by 5. So I will have correspondingly, I will have 5 absolute errors. Delta x1, delta x2, delta x3, delta x4, delta x5. So out of these 5 errors, which one to consider? Which one is the best possible error? So the best possible error will be the average of these individual absolute errors. That means the best possible error, now let me denote it by delta x. This will be equal to, mind that this is the best possible error. This delta x is the best, means the most accurate error, absolute error, or you can say error. Best possible error. This is delta x, and this will be equal to delta x1 plus delta x2 plus delta x3 plus ... If there were n observations, then delta xn divided by n. That means average of the absolute errors give me the best possible error. How much is the error? Now I have calculated it is delta x. What was the true value? It is the average of all the individual measurements. It is the average of individual results that I have obtained while measuring the length. Say length. It is true for all physical quantity. Now how much was the error that I committed during my first measurement? During my first measurement, how much mistakes I have done? It is delta x1. During my second measurement, how much was the mistake? It is delta x2. During my third measurement, how much was the mistake that I committed? Delta x3. During my nth observation, how much was the mistake? It is delta xn, whose numerical values are nothing but x average minus x1, x average minus x2, and so on. So out of these individual absolute errors, which one is the best? This is the average of these delta x's, delta x1 plus delta x2 plus delta x3 plus delta xn divided by n. So average of absolute errors give me the best possible error. You remember. So we have got two things, the true value as well as the error. True value as well as the error. Therefore, how to express the result? How to express the result? Suppose, before I write the expression, let me explain. Suppose the length of the pen, true value, say it is 5.5 centimeter, and the amount of error, say it is 0.2 centimeter, amount of error, delta x. Best possible error, let it be this one. And the true value, that is average of all your measurements, say it is 5.5. Then what is the result? How will you express the result? That is very, very important. So I will say that the length of the pen, let it be L, this is equal to 5.5 plus minus 0.2 centimeter. Error can be positive as well as negative. I don't know on which way it is. Therefore, we write it to be plus minus. It can be positive, it can be negative. Therefore, you have seen that if you would have been asked to give the length of the pen, then this is the way how you are to express the result. So in general, for any physical quantity, it can be length, breadth, volume, anything. In general, if you wish to measure any physical quantity denoted by x, this is similar to your length, L. If it is length, say it is L. But I don't know which physical quantity, so in generalizing term, I can write it to be x. So in general, any physical quantity after its measurement can be expressed as, here you see it is 5.5, it is nothing but the true value, and true value is nothing but x average plus minus delta x. So you remember, this is the final form of the result, how we can express a physical quantity. So result of any physical quantity x will be expressed in the form x equal to x average plus minus delta x, where delta x is the average of absolute errors. We know how to evaluate the absolute errors, and x average is nothing but the true value which results from the average of all the individual measurements. Fine? Now imagine a very peculiar situation. Suppose let x is the length. Suppose this x represents is the length of a body. Suppose I have said that this x represents any physical quantity. Now it can be length, volume, breadth, anything. So suppose x represents the length of a body during whose measurement x is the length of a body during whose measurement x average came out to be 10 meter and delta x came out to be plus minus 6 meter. In that case, the length of the body x will be 10 meter plus minus 6 to, okay, then it will be 10 meter plus minus 6. That means the results, it can vary from 4 meter to 16 meter. Will you accept if I give any object and ask you to give me the length, and if you say that the result could be anything in between 4 meter and 16 meter, it will not be acceptable. Fine? So there have to have some parity between the results with its respective true value. So we have to have a mechanism of finding out how much error have been committed. How much is the amount of error in terms of percentage. So for that we define another term which is called fractional error. Fractional error or relative error. Delta x is the average of absolute error, the best possible error. Now fractional error or relative error is nothing but delta x by x. This x stands for this x, this delta x stands for this. So fractional error or relative error is expressed as the best possible error divided by the result x, Percentage error, another term, percentage error. We will be doing few numericals, then you will understand all these things actually very nicely. Percentage error gives me the result. The expression of percentage error is delta x by x multiplied by 100. This gives me the percentage error. If you are being asked to give the percentage error, this is the formula. Fractional error or relative error, this is the formula. You have to express the result, this is the formula. So you remember these three. This is how we represent any physical quantity. Here I have shown that if the average length of a body is 10 meter and you said that the result could be anything in between 4 meter and 16 meter, it is not acceptable. So it is very important to get to a situation where we find that our random errors is not very big, because if random error is big, here you see the random error was 6 meter, and therefore we have got a very wide domain of result, wide domain of values, which is not acceptable. Now another term, fractional error, which is nothing but the ratio of the absolute error to the respective value of the physical quantity. Another term, percentage error, it is delta x by x into 100. So our first class ends here. Thank you.